We've already looked at pyramids and cones in 11.3 and found their surface areas. Now we're just shifting our focus a bit to volumes of the same shapes. So volume of a pyramid is related to volume of a prism that has both the same base and height. And the way that it's related is with our volume formula. The volume of that pyramid is going to be 1/3 of the base area times the height. So you can remember back to a prism that was just base area times height. If I was splitting that figure into a pyramid, that would be 1/3. And basically this formula comes from the fact that I could fit 3 pyramids inside of a prism of the same base area and height. Since I'm just looking for one of those pyramids, I'm just taking 1/3 of that formula. So that volume formula is true for any pyramid that we have. So I could have an oblique pyramid like this example here where I don't have the height within the center of that figure. And height in any case is just the perpendicular segment that goes from the vertex to the plane of the base. So we still find height the same way that we did for the surface area. So if we're using that formula to find volume in our first problem, we're given a few measurements in that diagram. We're told that the entrance to the Louvre is a square pyramid with a height of 21.64 meters, and we want to use that to find the volume. We're also given, it looks like in the figure, a side of the base, which would be 35.4 meters. And if I just use my formula, 1/3 of the base area times the height, since our base is a square for a square pyramid, that'll just be 35.4 times 35.4 for the base area. So if I square 35.4, I should get 1253.16. And we're also told the height of that pyramid in the question itself, that was 21.64. If I just substitute those two values in, 1/3 of the base area times the height should come out on that one to be about 9,039. So again, we just need 2 things to substitute. That's base area and height. Same thing on problem 2. If we're trying to find the volume in cubic feet of this square pyramid again, this time the base edges are 40 feet and we're given a slant height of 25 feet. We're still using the same formula. It's still 1/3 of the base area times the height. And just like the last one, base area should be pretty simple if it's a square. 40 times 40 gives us 1600 for a base area. This time though, for slant height, if that's given, I'm going to have to use our right triangle again to find the actual height of that pyramid. So if I use the slant height as 25, and remember not the entire 40, but since we're just going to the middle of that pyramid, we're going 20 for the bottom side of this right triangle. And if I have 2 sides of a right triangle, I should be able to find the third side by using Pythagorean Theorem. So we might be able to remember this as a triple. This is in the form of a 3, 4, 5 triple. But even if not, I could set up a squared plus b squared to be equal to c squared, where c is the hypotenuse of 25. And if we end up solving that for the height, we should end up getting a 15. So then once I substitute those two back in, volume again is 1/3 of the base area that we found before, times the height of 15. That should just give me 8,000 on the dot in terms of cubic feet. Next question, same sort of idea. We're given a square pyramid. We're also given a base edge and a slant height. So if I'm looking for the volume, still 1/3 of the base area times its height. Base area, again, since it's a square, would just be 24 squared. So that's 576. And same thing we did last time. If we're given a slant height, that would be going up the side of the pyramid. So if I want to go right through the middle, I'm going to have to use that right triangle. So 13, again, is the hypotenuse. Half of your base edge would be 12. So that would be the side that goes towards the middle of that pyramid. And we're going to use the Pythagorean Theorem to find the last leg, which is your height. So same thing, we could remember this as a triple, but also if I just do a squared plus b squared equals c squared, that should eventually be solved to get a height of 5. So plugging those back in, we have volume, which is 1/3 of base area times height, should come out to 960, and that's cubic meters on that last problem. So if I want to look for a cone instead of a pyramid, that's also related to the volume of a cylinder with the same base and height, just like our prisms were. And we derive the formula a similar way as well. Cones and cylinders have the same base and height, so if I line the cone up with the cylinder, it should fit right over the top. And it takes 3 cones to fill up the cylinder, so kind of like what we saw with our prisms and our pyramids, if 3 cones fit into the same shaped size cylinder, we're going to have a similar formula for the volume. So volume, just like the prisms, is going to be 1/3 of the base area times the height. And sorry, I said prisms, but that was pyramids, was 1/3 base area times height. And the formula you can get more specific on with a cone, since your bottom base is always a circle, we can always just substitute instead of that capital B for base area, that's always going to be a pi r squared. So we're finding the area of that circle. So should be pretty quick on this. As long as we're able to get a radius and a height, we should be able to find our volume. Looking at our first example, I'm going to kind of skip past the word problem a bit, but basically what we're taking from that is the volume that we're looking for should be, again, 1/3 of the base area times the height, where base area is just a circle, so that's pi r squared. If we're given a base diameter of 14 feet, that means the radius that we're using is 7, which is half of that. And we're given the height directly as 12 feet, so if I just substitute those two values in, 1/3 times pi times r squared, so that would be 7 squared, and height is 12. If I substitute that in, that should all come out to 196 pi, or also 616 cubic feet, if we're rounding that to nearest unit. So same type of question coming up next, the volume of the oblique cone to the right we want to find. And again, just like the last one, we can answer either in terms of pi, or we can round that to nearest cubic foot. For volume, is still the same formula, 1/3 pi r squared times height. Again, that pi r squared is kind of like a base. This time, if I know the diameter is 30, just got to cut that in half to get a radius of 15. We know our height, even if it's not in the center of that figure. This would be an example of oblique cone. As long as it's perpendicular going from the vertex to the base, that would still be your height. So that's 25. And substituting those two values in should get you 1875 pi, or also 5,890 cubic feet, either answer. So if we want to expand on that a bit and find a different sort of shape, we're looking at spheres in 11.6. So we're doing both surface area and volume because we're just focused on one shape, and that would be a sphere. So first of all, a sphere is the set of all points in space that are equidistant from a given point that we call the center. So you can imagine kind of like a circle just in 3 dimensions. Radius, just like we have radii for circles, it's going to be a segment that has one endpoint at the center and the other endpoint on the sphere. So it looks similar to when we're doing a radius just for a circle. Diameter is a segment that passes through the center with endpoints on the sphere. So same idea as when we had diameter for a circle. Should just go from one point of the sphere to the other, going through the center. And we can find surface area and volume of a sphere as long as I just know one part, just need to know the radius, kind of like when we were just dealing with circles. So also we have a few other parts of the sphere we could describe. When a plane and a sphere intersect in more than one point, the intersection is going to be a circle. So this would be like taking a cross section of this area up here, forms our circle towards the top. If the center of the circle is also the center of the sphere, we call that the great circle. And there's only one of those in your sphere. You can kind of think about taking the exact halfway point, going through the center of your sphere will also make what we call a great circle, if I look at the cross section. Circumference of the great circle is what we refer to when we say the circumference of the sphere. So again, that's just halfway around your sphere. Halfway down, I have an upper part and a lower part, which means that I've divided that sphere into 2 hemispheres. So you can think kind of like a globe, how I have a northern hemisphere, southern hemisphere, and how we have like that equator as the great circle. So if we want to model a sphere, we can do that by looking at, for example, a baseball. Surface area of the sphere is the area of the 4 circles that we can unravel to make that baseball. So if I have 1, 2, 3, 4 circles that I can stitch together to make a baseball, the area of the sphere is going to be the area of all 4 circles. So that would be 4 times pi r squared. And that's the only formula we're focused on for surface area. Again, if I just want to find the surface area of a sphere, that's going to be 4 pi r squared. So we can think back to that baseball as stitching together those circles. Since I have 4 of them, that's 4 circle areas. So solving these should be pretty fast. All you have to do is decide on a radius, because that's the only value that's being substituted. It's our only variable. To find the surface area of the sphere in terms of pi, in this example, if I'm given a diameter of 10 meters, I just got to cut that in half first to find a radius of 5, and then just substitute that in. So 4 pi r squared would come out to 100 pi square meters. Same type of question if my diameter is 14 instead. Again, all we have to do is look at the radius, and that would be a radius of 7, half of that diameter length. And substituting that in, 4 pi r squared, that should come out to 196 pi, or also asked to round that to nearest tenth, which I guess I skipped and just did nearest whole number, but that would be 616. So just 4 pi r squared, as long as we have that, we have the surface area. Could be asked questions like this next one, though, where we're told the Earth's equator first is 24,902 miles. So we're going to use that to find surface area instead of just being given a radius. So we can still find the radius based on our first piece of information. If I know the equator, if I look at one of these examples, that would be like a circumference of the great circle. So if I know the circumference of my sphere, then I know a way to find the radius, because circumference is just 2 pi r. So if I want to find the radius from that, I'm going to solve and isolate my radius. So if I divide both sides by 2 pi, the radius should come out to be about 3,963.3. And then if I'm substituting that in my surface area formula, 4 pi r squared, that should come out to, I have it over here, 197,390,000 square miles. Don't have to be as exact because, again, we're rounding a little bit when we're finding our radius. So if we Google that, if we look that up, it should be pretty accurate for surface area of the Earth. After surface area, we also have volume. So the volume formula for a sphere is going to be 4/3 times pi r cubed. So again, just like surface area, the only thing that we're going to have to look for and substitute is that radius. As long as we have that, we can find volume and surface area. So first question, if we're finding the volume of the sphere in terms of pi, as long as I know that the radius is just 6, that's the only thing I'm substituting, again, because volume is just 4/3 pi r cubed. If I plug that all in, I should end up with 288 pi, and that would be, again, cubic units, so cubic meters. So next question, if I know the diameter of a sphere of 60, the only work we have to do on this one is look at half of that length, because that would be our radius. And after I substitute 4 pi r cubed, that should come out to 36,000 pi, or also, since we're asked the nearest tenth, that should end up being 113,097.3, and that's cubic inches. So we might also have questions where, again, we only know the radius, so we have to just use that to find the surface area. So if I'm given the volume, I can find the surface area because they should have a radius in common. So that would be a question like number 4. If I'm told the volume of the sphere is 5,000 cubic meters, that's really telling us what to substitute in our volume formula of 4/3 pi r cubed. We're not plugging in 5,000 for radius, we're substituting 5,000 in for the measure of the volume, and we're using that to find the radius. So if I wanted to isolate radius from that formula after I plugged in the 5,000, we'd have to multiply by the reciprocal of 4/3, which is 3/4. That would cancel our fraction. If I wanted to cancel pi, I could just do that by multiplying 1 over pi, or you can think just dividing pi as well. And that should come out to 3750, and then that's over pi again. So if I have r to the 3rd power, I can isolate r by taking a cubic root. So if I take that cube root of that result that we found before, your radius here should come out to about 10.6. And again, since that's the only thing that we need to substitute in our surface area formula, it's 4 pi r squared. After I plugged in my 10.6 from the first part, I should end up with about 1,414 square meters. And there is another question on the back, but I think we're going to do that in class together as a little bit of a practice and check to see if we know how to do these steps. Make sure everything else is filled out and come ready to do some practice.